Yeah, hello, good evening, everyone. So, any doubt in the previous session?
Ma'am, just one thing I wanted to ask.
Yeah,
What is this HG38? HG for human genome, I understood might be for a human genome, but 38 and for a mouse you said 39. So what is that number I wanted to ask?
ma'am, this is the assembly ID they are providing, na?
Okay.
The NCBI ID. Okay, just for the recognition. So, for example, like you are having the SG38, and let me just show here.
Is it specific for the species? Like, is it
Yes, ma'am.
38
Yes,
is for human and
exactly. For the mouse, that is the ma'am.
yeah, that I understood. Yes, MM stands for
Yeah.
mouse.
So, for example, like you are telling me this SG38, right?
Yeah, yeah.
And if you see here, it is the 19 here, right?
That is what I wanted to
So,
ask.
this is the older assembly, ma'am, they are giving you. Okay. And if you go to this SG38, this is the updated assembly of the human. So this
Okay.
like NCBI, or you can say the people who are working in the NCBI database, they are ma'am assigning to the assembly, not us.
Yeah. Okay. Thank you.
Okay.
Yeah.
Actually, this is just a like you can say the reference ID for the human. That's it.
Okay, ma'am. Thank you.
Yeah. But make sure the assembly ID is different for different organism. Okay. Let me just start. So like everyone is having this BAM file.
Yes, ma'am.
So what we saw till now, like we downloaded the raw data from the NCBI SRA. Once we have a like raw data, we need to check our quality that we did with the help of fast QC tool. So in the fast QC report, what we saw, they were adapter and the primer sequence, and that we have trimmed with the help of fast P tool. So after trimming, we need to again check the quality of our data. Then we run it again the fast QC. And what we saw, all the adapter and the primer, or you can say the unwanted sequence, were removed from our data. So now you are having a good quality. So next thing is that we have to align our reads from our raw data on your reference genome. So make sure whenever you are like having the real project, okay, that time you have to completely download the entire genome of the organism. So for now, just to make like easier for you guys, because you are also new to this pipeline, that is why I have just taken only chromosome 17, because here we are going to analyze only TP53, which is present in the human. Okay, so that analysis we are going to see, and in the NCBI, what we saw, the TP53 were present in the chromosome 70. That is why we have taken this as a reference. Then why did we did the indexing, Raki?
Ma'am, because the genome is very large, so we'll have to.
Exactly. To reduce the time of the alignment. And second thing is like the reference genome, it is in the FASTA format, that is the ATGC format. So whatever the tools we are going to run in the pipeline, that cannot read the ATGC sequence, because this is not the computer readable file. That is why we are just converting this reference genome into binary files that we saw here. These are the binary files. This one. Okay. Till this. Not the Chrome. This one. So next step is we have to align our read on this binary files with the help of same tool, that is the BWA. Then we have used the BWA mem options. Hyphen T is the thread. This is the index genome. And here you have put your input file. And this is we have created the output in the BAM file. So it is the binary file here. So what if I want to read how the reads have aligned on our reference genome? We should know now, like where it is present. So for that purpose, we are going to Just right here, step 5. We are going to convert BAM into SAM file with the help of, or you can say by using SAM tools. So SAM tools, what is that tool? The tool which will convert BAM into SAM file and SAM into BAM file, and it contain all the mapping information. So how to install this SAM tools? So we have installed the SAM tool using the repository method, that is the sudo apt -get install SAM tools. So now everyone can open the WSL. So make sure everyone is having the SAM tools in their system. If you are not having, you can install by running this command in the terminal. Just open the manual by just writing the SAM tools. Now you can see the SAM tool it is there. This is the manual. That means it is like installed properly. Okay. So now what is the command to convert the BAM into SAM file? So you have to call the SAM tools. Then we are going to use one option, that is the view. So now you have to give your input file name. So this is my input file name now. And then put greater than sign and put your output file name. Okay. So I'm going to convert this BAM into SAM. So this is my SAM tools view options I'm using. This is my input, which is in the BAM file. Now I'm going to generate what the output file in the SAM. Clear this command? Now just copy this and run it on the terminal. So you can see I have taken the option from here, SAM tools view. You can see it is taking a lot of time here, and we have just taken only chromosome 17. So imagine like in real time when we are having the entire genome of the human, so how long it will be taking. right? So that is why, like, before this we did the indexing. So did you got the SAM file in your system? So this is the output. You can see it is in the SAM file. So tell me, like, can we move ahead if you have this SAM file in your system? Just let me know. Is it generated?
No, ma'am, not yet.
Okay. No problem. Like, by the time you can see whatever the contents that the this file it is containing, I will tell you. So for example, I want to see on this terminal. So what I will do, I will just write here header command, and I want to read only 7 file, or you can say the 7 lines from this SAM file. So I will just give here hyphen, then 7, then give your input file name. This is my input file name now. Now enter. Now you can see this is the content that SAM file it is containing, right? So you can see the IDs, the chromosome location, but still we are getting confused. What is the content, right? You are new to this SAM file. So let's see what is the content that is present in the SAM file. So how we can read this SAM file. Can you see this table? This one?
Yes, ma'am.
Okay. So this SAM file is basically like it is containing what the mapping information, and it is having the 11 columns for the alignment. So you can see here the 11th columns here. So let's discuss one by one what is the column. Okay. So how we can interpret from our result. So first field is the Q name. So Q name is what? The query ID. Then flag is what? Whenever you are doing like any analysis, so there is a null statistics are generated by the tool. So we are going to ignore this flag because it is not going to give any information which is related to the alignment. Next is the R name. So R name means on which reference your query is aligned. So I will just tell you along with the diagram. For example, this is my reference, right? So on this reference, what happened? The query it is aligning. So first column was the query ID it is giving, and the R next means, so this is my chromosome 17, right? We have downloaded. So this third column is what? The R name. So on which reference it is mapping. So can we say this read it is mapping on the chromosome 17. So that chromosome 17 is what? The R name here. Next is the position. So position means the actual base of this read on your reference. So that position it will give you. Okay. Next is the mapping quality. So can you tell me what is the mapping quality now? Like we have discussed during the terminologies also in during the introduction. Can you tell me what is that? Mapping quality. So mapping quality means how accurately the read it is aligned on your reference genome. Okay, so make sure your mapping quality should be greater than equal to 30. Okay, so that will indicate our reads is having the good quality. Okay, so that number it will tell you. Then the cigar string value. So cigar, what is the cigar string value now? So how accurately the base of your reads are lining on the reference genome. So for example, this particular reads, it is having what? The 50 base pair, and all this 50 base pair it is mapping, or you can say the matching on your reference genome. So what is the cigar string value for this? 50m. Okay, where this m is indicating what? Like the all the base of the reads are like similar to your reference genome basis. Got it? The cigar string value. Till now it is clear. Any doubt till the sixth column? Anything you want to know? Clear?
Yes, madam.
Rakhi. Okay. Next is the R next. So R next is the position of the another read. Okay. So this is the R next. P next. Actually, in the R next, it will give you the read, and in the P next, it will give you the location of this R next. Okay. That position they will give you. Then T length. So it is the actual length of the read they will give you. Then particular sequence. So this is of 50 base pair. This is the actual length of the read, and then ATGC sequence they will give you here in the sequence. Then call. Again, it is the quality score of the read, which should be more than 30 and equal to 30. So that will give you, which is in the form of ASCII characters. So what is the ASCII characters? Any idea? So whenever you are having a FASTQ data, so this file, it is what? The raw data, okay, that we have downloaded from the NCBI SRA. Okay, so this FASTQ data, it is containing what? It is a 4-line format which is equal to one read. Okay. So one read, it is containing 4 lines. So if you are having 40,000, one more. For example, you are having if 4,000 lines. So how many reads it will be there? Can you tell me? Tell me. If you are having 40,000 lines, so how many reads it will be there?
10,000.
Yes. Who's this?
Akanksha.
Oh, nice. So 40,000 you can divide it by the 4, then you will get what? The 10,000 reads. Okay. So it will be equal to 10,000 reads. So let me tell you what is the 4 lines here now. So first line, it will contain what? It will start with the add the rate, and then it will give you the ID of that sequence. Then second line, it is having what? The actual sequence. Third line, it is containing what? The special symbol. For example, plus. Which is a separator line. So it will separate the fourth and the second line with the help of some symbols. And fourth line, it will contain what? ASCII characters. So it can be this. So FASTQ data, it is containing 4 lines. First line will have the ID. Second line will have the actual sequence. Then third line, it will have a special symbol which will separate the second and the fourth line. And fourth line will have the ASCII character which is representing the Fred quality score. So why they are converting this scores into this ASCII characters? Can anyone tell me? Why they are not taking the actual score directly? Any idea? So machine is converting Fred quality score into a sky character with the method encoding. So encoding is what? The conversion of Fred quality score into a sky character. Why? When you are having a Fred quality score in your FASTQ data, the file size of your data will be a huge. So in order to reduce your file size, the machine is converting the quality score into this sky character. Okay. So already you know this FASTQ data, it is containing 4 line. Can you imagine 4 line? It is huge, right? And you already know the data, it is containing multiple reads there, right? So in order to reduce the file, they are just converting this Fred quality score into a sky character. That it is what the qual here. Okay, so let's discuss what are the content that is present here. So this is your query ID. Next is the flag score. Then this is the location. or you can see the R name. R name is what, on which reference your query is aligned, that is the chromosome 17. So for now, everything will be chromosome 17 only. Why? You have taken only chromosome 17 as a reference, right? But in real time, you will get the like different chromosome in your SAM file. Now, next is what? The position, the actual position of the query on your reference. Then this is the mapping quality of this particular read. Then this is what the cigar string value. So 151 base pair were there, which is matching exacting, like it is exactly matching on your reference genome. Okay. Then R next. So sometime like the tool it is not able to read, so they are giving some this character, so you don't need to worry. Along with that, they are giving the position of the R next read. Then this is what the T length, you can say. This is the actual sequence. Okay, till here. And remember that this is not a sequence. So this is what till here. Yeah. So till here, this is I call. This is the quality score of the read, which is like indicating in the form of a sky character. So this is a sky character. Okay. And this NM, MD, MCAS. So this is nothing. This is just a extra information. So you don't need to worry about this because this is not a alignment information. So got it? What are the content that is present in the SAM file? Any doubt in the SAM file? Clear?
Ma'am,
Yeah.
ma'am, why the that 158 thing is in a negative
Which
and
one?
for ma'am in the second sequence after the sequence starts. Ma'am, this plus 158 and then minus 158.
This one.
Yes, ma'am.
Ma'am, this is in, it is in the reverse strand, no?
Okay.
Yeah. Clear till here? Any doubt in the SAM file? All the 11 columns are clear? Anything you want to know? Now you can see on the terminal, like this file, it is already sorted. Okay. But in real time, what we are doing, we are mapping on the entire reference genome, right? So you will get the data like this. So for example, like this is the SAM file and you are getting a information like this, okay, randomly placed. But what if I want to arrange my data according to my chromosome position? Okay, so this is randomly placed. Can you see that? Chromosome 1, chromosome 16. What if I want to see my data like this? Chromosome 1, then I want to know what are the reads that are mapping on the chromosome 2, then 3, then 5, 6, 7, 8, like this. Okay, so for that, what next step we are doing? We are doing the sorting on the base of chromosome. So next step is what? The convert of BAM into sorted BAM file. Got it? What is the sorted one now? why I have like converted this into SAMs in order to show how the mapping reads are looking like. Okay, so that is why I've converted this into SAM. Okay, but in real time we are taking this as the input only, the BAM file, because rest of the tools we are going to run on the binary files only. So that is why I'm going to convert this BAM into sorted BAM file on the basis of chromosome. So let's check what is the command for that. You just open the manual. So you can see the option is sort. Now I'm going to use this sort option, and you can see the manual, it is open. You need to call the SAM tools, then sort. Again, it's up to you, whatever the option you want to use, like during the command, you can use that. So I will tell you what are the options I'm going to use. Just write here SAM tools, then sort. Then I'm going to put a input file. This is my input file name. Then I'm going to convert into sorted. So this is my now output, which will be in the sorted manner. Now just copy that command and then run it. Any doubt in the SAM tools part? Anything? Is it SAM file? It is clear? Kansha ma'am, Abhishek, Rakhi, Sarvanand sir, Jai Ganesh.
Yes, madam.
Okay, fine. So everyone can run on their system this command. You need to convert this BAM into sorted BAM file. Now you can see it has generated the sorted BAM file now. So it is having the mapping information. Okay. So now next step is to, so in the DNA sake, remember the step RMDUP. So this is the important step in this pipeline. So this is the step 7. To remove duplicates using SAM tools. So can you tell me what is the duplicate reads? Any one of you? What is the duplicate reads?
Over representation.
Okay. Rakhi, what is the duplicate reads?
Ma'am, this was me only. Ma'am, when there are
Okay.
extra or
Akansha ma'am? So for example, you are having a one read and it is sequenced multiple times, okay, during the sequencing. So it is creating what? The identical reads on particular one position. So it is causing what? The duplicate reads. Okay. So sometime like during analysis, like it is giving you the false result also. That is why this is very important in the DNA stake. That is the RMDUP function. So that also we are going to remove with the help of SAM tools. So let's see. Uh, okay, let's make the command for that. Again, you call the SAM tools. Okay, let me just show you the manual first. Yeah. Now you can see you need to call the SAM tools, and here I'm going to use one of the function that is the RMUD DUP, then hyphen like small s and capital S. So hyphen S is whenever we want to remove the duplicates from the single end read. Hyphen capital S whenever we want to remove the duplicates from the paired end data. So whenever you are having the paired end data, so SAM tools RMDUP, what it do, it is going to treat this paired end data as the single end. So that is why we are forcefully running this. Okay. So you have to use this command SAM tools RMDUP hyphen S capital S, then give your input file name, then this is your output file name. Now let's make the command. Now what is my input file name? Can you tell me? What is the input now?
sorted DAM file.
Yes. So this will be my input. So now I'm going to give the name, that is the RMDUP, so that we can remember like this is my output of your RMDUP. Okay. So just give this. So now this is the command. You can run this. You are also like having the same problem, guys, in the RMDUP.
Yes, ma'am. It is not opening, running actually.
Can you share your screen, Akansha ma'am? What is the error you are getting?
Wait, I'll share.
Yeah, share.
This is,
Mm,
it is just opening the manual, I guess. It is just telling the usage.
yeah.
Should I stop, ma'am? Stop
Yeah,
share.
same the error you are also getting. Mm, let me just see the pipeline. Maybe the name like we haven't put the same sorted.
Ma'am, I guess removing that greater than sign will do it.
Yeah, it's working now. Yeah, there was a space, and also like I have put here the greater than sign. So I thought like it will work, but it is not working. You can remove this greater than sign from the pipeline also. Make sure you are not having like big space here after this. You can run now this command. So you can see here, like in the RMDUP, uh, this is the total reads that were processed, and this is the duplicates it found, and the percentage of duplicates that you can see here. So that it has removed with the help of SAM tools. Okay. So now, like further, after removing the duplicates, we are going to call the variation using the GATK tool. So that calling of variation we'll see on Monday, guys. Okay. So you can tell me if you are having any doubt till the step 7 RMDUP. Anything you want to know?
No, ma'am.
Okay. Is it clear for everyone? Akansha ma'am, Abhishek, Sarvanand sir?
Yes, ma'am.
Okay.
Yes, ma'am.
Okay then. Okay then we can end it here and we'll meet on Monday because Saturday, Sunday will be your off, guys. Okay? You can practice this till the RMDUP and on Monday we'll see how to call the variation using the another tool. Okay? Okay then. We can end it here. Bye bye.